All right, here's the video notes for 2-3 trigonometry. So in order to use trigonometry, we need to understand the relationship between the angles and the sides. So we're just going to learn some various parts of a right triangle and kind of go from there. So let's start with something that we are familiar with, and that's going to be our hypotenuse. So our hypotenuse is always across from our right angle. So I'm going to label it. Use our different color. We're going to label it H, and we're going to highlight our hypotenuse as best as I can. Let's see if I can highlight it using this. Okay, the hypotenuse is the easiest thing to identify because it never changes. So this is the hypotenuse, and it never changes. It's always across from the right angle. Okay, what I like to do is I like to highlight our hypotenuse. It makes it easy to find, okay? So our other two sides are going to be determined based off of whatever angle we're looking at. So that angle is going to be called the reference angle, and we usually use the Greek symbol theta, which looks like a circle with a line through the middle. So this is theta, and this is a reference angle. It's like your reference point. Okay, and we highlight our hypotenuse. So what I usually do for the reference angles, I like to circle it. Okay, so based off of wherever theta is, that's what how we're going to label our other two sides. So if our reference angle is here, the two other sides are called the opposite side and the adjacent side, and that's in relation to our reference angle. So looking at our reference angle here, the opposite side is going to be the side that is opposite to the reference angle. So using this as our reference angle, this is going to be the opposite side. So we're going to label that O. And it's opposite to theta. And we're always going to label it with an O. And then the other side is called the adjacent side. So that's going to be the side closest to the angle. So this is the adjacent. And it's the side closest to theta. And we're going to label it with an A. And your reference angles usually, whatever's angle is given to you in the problem. So usually only one of your angles is given. That's what's best to use as your reference angle. Although it doesn't really matter. You can use this angle as your reference angle. That would just mean your opposite and adjacent sides would probably switch. One thing you can think of is that your reference angle is always made up of your hypotenuse and your adjacent side, and the opposite side is just the furthest one. All right, so just a little bit of practice naming sides. So looking here, we have, if A is our reference angle, we're going to label opposite, adjacent, hypotenuse. So A is the reference angle, so I'm going to circle that. This is our hypotenuse because that's across from our reference angle. The adjacent side is the closest side, so this would be my adjacent, which would make this my opposite side. Okay, now using B as our reference angle, our hypotenuse doesn't change. The adjacent side is now the one closest to the angle, so this would be A and this would be O. It says using B as our reference angle, so there's B, label the sides. Hypotenuse is across from my right angle. The adjacent side is the one that's closest, and our opposite side is the one that's furthest. Okay, so we kind of get the picture. All right, so now that we know how to label our sides, now let's introduce you to the trig ratios that we're going to use. So the three trig ratios we're going to use is sine. So this is sine. This is cosine. And this is tangent. So for short, it's SIN. COS, and TAN. So those are three trig ratios, and it basically describes the relationship between two sides. Sine is just a function, so when we take the sine of our reference angle, it's going to be equal to the ratio of our opposite over our hypotenuse. So if we take sine of whatever the reference angle is, that's going to be equal to the opposite side over the hypotenuse. The cosine ratio is going to be the adjacent over the hypotenuse. And our tangent ratio is going to be the opposite over the adjacent side. Sorry for my terrible handwriting. So the way that you can remember these trig ratios is the acronym SOH-CAH-TOA. So is sine is opposite over hypotenuse. Cosine is CAH, adjacent over hypotenuse. And tangent is TOA, opposite over adjacent. So you can use these ratios and this relationship between the reference angle and the sides to solve for missing sides in triangles when you're only given maybe one side, and you can't use Pythagorean theorem, nor can you use special triangle relationships. Okay, so real quick, when we're using our calculator, we need to make sure that our calculator is in the correct mode. So our calculator has two modes, radians and degrees. In order to use trig with degrees, we need to make sure our calculator is labeled in degrees. So we can switch here between radians and degrees. Desmos defaults to degrees, so you shouldn't have to do anything. But if your calculator is in radians, you'll know. So to check, you can do sine of 41, and that's 0.656. If your calculator was in radians, it would give you a negative number sometimes, or at least for sine 41. So sine 41 should be 0.656, et cetera, et cetera. That's how you know that your calculator is in the correct mode. All right, so now using our trig ratios, we know that sine is SOH-CAH-TOA. Sine is opposite over hypotenuse. We can, using A as our reference angle, let's label our sides. So 10 is your hypotenuse, 8 is your adjacent, 6 is my opposite side. And now we can set up our ratios. So if we take sine of A, our opposite side is 6 and our hypotenuse is 10. What we can also do to that is just figure out what that is as a decimal, so 0.6. Okay. Cosine of A is going to be adjacent over hypotenuse, so that's going to be 8 over 10, which is 0.8. Oops. So you can write it as a decimal or a fraction. And tang A is going to be opposite over adjacent, so 6 over 8, which is going to be 0.75. Okay. Then what we can do is we can actually switch reference angles, now using C as our reference angle. Well, we know that our hypotenuse doesn't change. However, the opposite side now becomes the adjacent, and the adjacent side now becomes the opposite side. And now we can set up our ratios. So sine of C is opposite over hypotenuse, so that's going to be 8 over 10, which is 0.8. Cosine C, adjacent over hypotenuse, 6 over 10, which is going to be 0.6. And then tan C is going to be opposite over adjacent, which is 8 over 6, which is 1.33 about. Okay, so one thing maybe you notice is that cosine of A and sine of C are the same, and sine of A and cosine of C are the same. So think about why that makes sense. Remember, when you switch your reference angles, your opposite and adjacent sides switch. Well, the only difference between sine and cosine, is that your opposite and adjacent side are different depending on whether you're using sine or cosine. With sine, you're using the opposite side on top. Cosine, you're using the adjacent side on top. So when you switch reference angles, you know that these are going to swap, so these should be equal. Okay, so now let's just go through how to actually use trig to solve for missing sides. So first thing we're going to do is we're going to highlight the hypotenuse in all of these examples. So the hypotenuse is always across from your right angle. So it doesn't matter where x is, our hypotenuse is always across from our right angle. And then what we can do, it says using the given angle as our reference angle, so I'm just going to circle those. We're going to label our sides. Okay, so looking at this top one, we know that this is our hypotenuse, this is the opposite, this is the adjacent. Reference angle, this is our hypotenuse, opposite, adjacent. Hypotenuse, this is the opposite, adjacent. Hypotenuse, this is the opposite, this is the adjacent. Hypotenuse, this is the opposite, this is the adjacent. And then we have the hypotenuse, opposite, and the adjacent. Okay, so now to figure out which trig function you're going to use, you basically have to figure out which side you're solving for and which side you're given. Based off of that information, it should tell you which trig function to use. Okay, so take this example for instance. We know that x is our hypotenuse. Here's my reference angle. All right, 15 would be the opposite side. This would be adjacent. So we're solving for x, and we're given the opposite side. So since that has an O and an H, again, using SOHCAHTOA, opposite hypotenuse, that means we're going to be using sine for this one. All right, here's another example. Here's my reference angle. This is the hypotenuse, opposite, adjacent. And again, we're solving for x, and we're given the 13. So that's the O and the A. So OA, that means we're going to use tangent. Okay, so going back to our examples here, we're going to take a look at this first one and see, okay, well, in this problem, we're solving for the opposite, and we're given the hypotenuse. That's OH. That tells me I'm going to use sine. Okay, let's look at the second one. I'm given the opposite. I'm solving for the adjacent, OA. That tells me I'm going to use tan. All right, so now let's figure out how to actually use these trig functions. So remember, the way it's set up is it's your trig function, then your reference angle, and that equals, since we're using sine, it's going to be opposite over hypotenuse, so x over 17. So then from here, the easiest way to solve it, I like to just cross multiply, so put it over 1. So x times 1 is x. And then we have 17 times sine of 31. So 17 times sine 31. Then we're just going to put that into our calculator. 17 times sine 31. Oops. We get 8.76. And then you're done. So let's look at the second example. Trig function, then your reference angle, equals, and then it's going to be, since we're using tan, it's opposite over adjacent, so 11 over x. Okay, so notice x is in the denominator this time, but regardless, the solving is still going to be the same. We cross multiply, so it's going to be x times tan of 27 equals 11 times 1, which is 11. Okay, however, we don't have x by itself, so we do need to take one additional step and divide. So now we're just going to put this in our calculator, 11 divided by tan, 27. We get x equals 21.59. Okay, let's look at this example. We're solving for the opposite side, or sorry, we have the opposite. We're solving for the hypotenuse. OH, this is going to be another sine one. So sine reference angle equals opposite over hypotenuse, 12 over x. Cross multiply. So we get x times sine of 69 equals 12 times 1, which is 12. So notice when x is on the denominator, we're going to have to do one more step. We're going to have to divide in order to get x by itself. So a final answer over here. So it's going to be 12 divided by sine of 69. We get 12.85. All right, this one, we're solving for x, which is the hypotenuse, and we have our adjacent. So AH, that's going to be cosine. So cosine reference angle equals adjacent over hypotenuse, 10 over x. Noticing that pattern, when x is on the bottom, we're going to end up having to divide, because when we cross multiply, we don't have x by itself, so we do have to divide. So 10 divided by cosine 65, we get 23.66. All right, this one down here, solving for the adjacent, given the hypotenuse. AH, that's going to be cosine again, so cosine 46 is equal to the adjacent over the hypotenuse. X is on top, so after we multiply, that should be enough. So x times 1 is x, and then we have 13 times cosine 46. So that's what goes in our calculator. We get 9.03. And then this last example, solving for x, which is the opposite side, given the adjacent OA, that means we're going to use tan. Tan reference angle equals, and then it's opposite over adjacent since it's TOA, x over 20. Cross multiply, x times 1 is x, 20 times tan is 66, is 20 times tan 66. We get 44.92. All right, now let's take a look at a couple of these practice problems here. So starting with this one, I'm going to circle my reference angle, label my sides. So x is my hypotenuse, this side's my adjacent, this is my opposite. So we're solving for the hypotenuse, and we're given the opposite, which tells me OH, that's so, I'm going to use sine. So sine reference angle equals opposite over hypotenuse. Using that little trick, we should know that we're going to end up dividing in the end when we cross multiply to get x by itself. So 17 divided by sine 65, we get 18.76 about. All right, now let's take a look at number 5. So number 5, circle my reference angle, label my sides. This is my hypotenuse, opposite, adjacent. Solving for opposite, given adjacent, OA tells me tan. So tan reference angle equals opposite over adjacent, x over 14. X is on top, multiplication should be the last step, so x times 1 is x. 14 times tan, a 38. Get 10.94. All right, then this last one, this is a challenge problem. We're solving for x, so this is actually going to be a two-step problem. So actually, first thing we're going to do is we're going to solve for this dotted line, the shared side. So circling my reference angle, this is my hypotenuse. This side we'll call y. This is my adjacent. This is opposite. To solve for y, that's adjacent and hypotenuse, I'm going to use cosine. Oops. So this is my hypotenuse. Sorry, I just deleted everything. This is my adjacent hypotenuse, so it's going to be cosine 70 equals adjacent over hypotenuse, y over 35. And then when we cross multiply, it should just be y equals 35 times cosine of 70. $11.97. Then what we're going to do is we're going to use, so now we have this triangle right here. We know that this angle is 32 degrees. This is x, and we now know this side is 11.97. So using this triangle, this is my reference angle, this is my opposite, this is my hypotenuse. We're going to use sine. So sine 32 is equal to 11.97 over x, opposite over hypotenuse. Cross multiply, so x times sine of 32 equals 11.97, and then we divide. So I'm just going to do the previous answer divided by sine of 32. You get 22.59. So just a two-step problem, solve for the shared side first. Once you have the shared side, you have another triangle, and then you can go ahead and solve for the side that you're looking for.